Hello all, welcome to Code Hub. Today let us solve the LeetCode's daily challenge and the problem is power of 4. Given an integer n, return true if it is a power of 4, otherwise return false. It is a straightforward problem. An integer n is a power of 4 if there exists an integer x such that n is equal to 4 power x. So for given n equal to 16, where 16 is a power of 4 since 4 power square 2, which is 4 square is 16, and 32 is not a power of 4, whereas 64 is a power of 4, where if we multiply 4 times, we get 4 into 4 16, 16 4s are 64, sorry 3 times. So that is the required problem. And how can we approach this problem? It is a simple straightforward problem. So to find whether n is a power of 4, first we can go for a brute force approach, where we can consider some sample test cases so that we may get clear. 4 we can write it as, sorry, 16 we can write it as 4 into 4, and n equal to 64 we can write it as 4 into 4 into 4, whereas if we want to find n equal to 32, we can't write in multiples of 4. 4 4s are 16, but it is 16 2s are 32. So we can see here, if the number is a power of 4, we can write it in terms of only 4. So what we can do is, if we divide continuously a number with 4, we end up getting a 1 or 0. If we end up getting a 1, we can say that the number is a power of 4. We can divide 16 by 4, it becomes 4 by 4, which is 1. If it is 64, if we can divide by 64 with 4, it will become 16, and 16 divided by 4, which is 4, and 4 divided by 4, which is 1. If we want to divide 32, 32 divided by 4 is nothing but 8, and 8 divided by 4 is nothing but 2, and 2 divided by 4, which is nothing but 0. So it is not possible whether for a number to be a power of 4, it should be ending up with 1 if we continuously divide it by 4. So what we can say is, we can run a loop n is greater than 1. What we can do is, if this n is going to be divisible by 4, only we have to do, else we can directly say return false. So what we can do is, we can just divide it by 4, else we can just return false. And finally, after coming outside of this loop, we can see n equal to 1. If n is equal to 1, then we can say it is true. It is a power of 4. So we can just run our code. So what will be the time complexity here? The time complexity will be log n. The time complexity will be log n to the base 4, and the space complexity will be order of 1. So this is a good approach to start in an interview. Let us submit our code as well. It got accepted. So this is one kind of approach. Let us optimize this approach and see what we can give the best to our interviewer. If our interviewer asks to optimize this code, what we can do is, we can try for a bitwise case. We if you do not know, I will say one technique to find a power of 2. There is a shortcut for using a bitwise operation. If we do an AND operation with n and n minus 1, we will get a 0. If we get n ampersand n minus 1 is to be 0, then we can say that number is particularly divisible, particularly a power of 2. So how can we extend this logic or this trick into our problem, into our current problem, which is power of 4? So to be a power of 4, what we can say is, first our n should be greater than 0, right? Yes, we can say that n should be greater than 0. and all the power of 2 should be a power of 4, right? If this power of 2, 4 is a power of 2, 8 is a power of 2, 16 is a power of 2, 32 is a power of 2, and 64 is a power of 2, and so on. 64, 128 is a power of 2, and so on. But so the power of 2 is nothing but even this power of 4 is inclusive inside this power of 2 as well. So first of all, the given number should be a power of 2, and then we can check whether this is a power of 4 or not. First we can write it this way. If this is equal to 0, then we can also say this is a power of 4. But if we get an input as 8 or 32, what will be our answer? It will return true, right? N is greater than 0, and this is also becoming true. So how we can differentiate between power of power of 2 and power of 4? That we will see in later video. I will wind up with this approach, and I will put another next video with using this bitwise operation.